We began our project with some basic research on concrete to familiarize ourselves with the material we would be working with. Here are some basic facts that we think everyone should know about concrete before getting their hands dirty. Concrete is a poured building material composed of several components, such as coarse aggregate, fine aggregate, cement, and water, with the ideal water to cement ratio being 1:2, and the aggregate affecting permeability qualities of the finished material. The general construction process of concrete can be broken into the following steps. First, build formwork. Next, measure out the components carefully for the mixture. Number 3, mix the concrete. Then, pour the concrete. This is when natural hydration and drying processes begin. Next, babysit the concrete. This may include troweling, tapping to remove air bubbles, curing, etc. Finally, strip the concrete formwork after 3 to 4 days. This is a typical strength gain curve of concrete. As you can see, concrete dries exponentially at first, gaining 75% of its strength within the first week. This dictates time schedules in concrete-based construction projects, as you can overlap subconstruction after significant strength gain in concrete. Concrete offers many perks for architectural projects. It's fireproof, it's easy to obtain, it's quick in construction, it's relatively cheap, it's strong in compression, and it's adaptable in color, treatment, permeability, finish, and form. Its strong aesthetic is the trademark of certain architects such as Louis Kahn, Pierluigi Leverance, and Matt Hall.
Spreadsheet shows the calculations we did to find the amount of ingredients we needed for each batch of 3 panels. Since we are given the quantities for a cubic yard of concrete, we first must convert them to the correct volume for our batch. We convert 1 cubic yard to cubic inches and then find the volume of our panels in cubic inches and add 20% as a contingency for waste. Then we divide the cubic yard by the batch volume to find the ratio we need to find the amount for each ingredient. Since this is a ratio, it will work for either weight or volume. For the standard impervious mix, we simply take the values we were given for Portland cement, aggregate, and water and multiply it by the ratio. Then we have the amount of concrete we need for 3 panels. For the countertop mix, it's a little more complicated because the dry ingredients are already mixed. The back indicates that it has 80 pounds of concrete and needs 2 gallons of water to properly hydrate it. To find the weight of the mix we need for the volume of our panels, we can use the ratio of 150 pounds of concrete per cubic foot. If we multiply the volume of our batch in cubic inches by this ratio, it will give us the weight of mix we need. Then, for the water, we use the ratio of 2 gallons of water for 80 pounds of concrete. Then we multiply this by the weight we require for the dry mix, so we can find the amount of water we need for that much mix.
For the first mixture, the conventional mixture, we mixed fine aggregate, number 57 coarse aggregate, Portland cement, and water in a crete sheet until an appropriate consistency was reached. After that, we poured the mixture into 3 panels. The conventional mixture required a trowel to distribute and smooth the concrete. Tapping or vibrating the edges of the formwork eliminated small air bubbles within the panel, reducing permeability. These basic steps were repeated for the following mixtures with slight variations. The second mixture, the colored pervious concrete, required the addition of number 89 aggregate and orange liquid cement coloring to cement paste in a crete sheet. After pouring, to avoid sealing the surface, a floater rather than a trowel was used to pack the mixture into the formwork. For the Quikrete self-consolidating countertop mix, we tried out some different ways to do formwork. First, we used chipboard to create a smooth surface. In the next panel, we used acrylic for a slick, shiny finish. In the next one, we used molding to create angled edges. And in the last one, we used styrofoam to create rounded edges.
After constructing formwork, 3 mixtures of concrete were poured to create a total of 9 panels. Mixtures varied by adjusting aggregate size, admixtures, and the type of cement used to produce a conventional, pervious, and self-consolidating mix. Formwork was altered using chipboard, acrylic, and molding to create various shapes, finishes, and textures. After hardening, tests were performed to evaluate permeability, strength, and durability of each mixture.
just actually trying to break this. Oh!
Ready? 3, 2, 1.
Okay, go.
We poured 2 panels in addition to the 9 which were required. The composition was similar to our countertop mix with the addition of a few key ingredients. In the first panel, we added wire mesh in order to strengthen the concrete and prevent cracking. The wire mesh was allowed to dry partially in the mixture and partially in open air in order to experiment with light and shadow. We chose to add styrofoam pieces into the second panel in order to make a panel of the same size as the first, but significantly lighter. This proved troublesome because the styrofoam is less dense than the concrete mixture, meaning that no matter how much we smoothed the surface, the styrofoam would continue to rise to the top, making it impossible to hide this material within the panel. The panel did turn out to be slightly lighter than the first, but more styrofoam could have been added in order to make this admixture more effective and worthwhile.
Formwork required the use of lumber, plywood, hammer, and nails. Lumber was cut to allow for 3 12-inch by 12-inch by 1.5-inch panels. Panels were arranged on the plywood to ensure enough space for expansion.